Welcome everyone, this is the Effects Masters program, lesson 9. Um, I've been away for a few days, trying to give you time to catch up with the assignments, so yeah, it's working well. I'm starting to see some cool stuff on the group. Keep experimenting, alright, keep trying new things and combining. That's the most important part, combining the concepts from class to class, okay? Lesson 9, it's not going to be with the sea lions. I changed my mind. I want to do something else beforehand, something that's going to help you. I'm going to open lesson 8. Don't worry, it says ESP for well, español, Spanish, but it doesn't matter. It's the same thing. I just want to get to this point where I get this scene file with the penguins. Remember? That's how we ended lesson 8. I haven't seen many tests yet from you guys about this topic or this lesson, but I understand that you're doing the best you can. You have to juggle your life and everything else, so it's fine. I don't mind. We have, like I always tell you in the course, we have plenty of time. We have, um, you know, you don't have to keep up with my rhythm, my pace. I took a few days to give you time, to give myself some time as well. Resolve a couple of personal things that I had to take care of. But yeah, don't try to keep up. Just do the best you can. But the only reason you should probably watch the lessons and then do the assignments later is just if you have any questions, just send them my way as soon as possible, so I can always put them in the next lesson. But for that, yeah, don't worry. I haven't seen many of this, but I think what we're gonna do right now is gonna help you quite a bit. So this is the lesson of the penguins, right? This is what we did in the Spanish class. So I'm gonna save this thing as lesson 9. Just call this lesson 9. I'm sorry, 1 second. Lesson. Okay, well, lesson 9. Yeah, perfect. All right. And I want to give you a couple of tricks. I think I want to throw you a curveball, like they say. I want to mess with you a little bit. So far, the classes have been progressively getting a bit more complicated. But every now and then, I'm going to throw you, like I say, a curveball. I'm going to give you something new, something different, and let you think about it and see what happens. There is a concept that we haven't explored yet. Because I know that you're going to be using the instancer quite a bit, because we have a few lessons left with it, and also because even though it's an old tool, it's quite powerful. So because I know these things, I want to give you something handy that you can use that's going to help you speed up things a little. So far, we haven't talked. We have only used one penguin or one piece of geometry. It's not animated, at least not the motion of the actual object, of the topology. It's not deformed. It's animated because we're moving the particle that carries the instance with the field. But that's it, right? So it's just the one penguin. And so far we used a medium-sized resolution. But what happens if you want to have a camera, for example, that flies over the penguins close by? Or what if it moves through them? What happens in the case? Do you want to? What if you cannot use a medium-sized or low-resolution penguin? What if you have to use a high-res penguin, right? If you need to have 20,000 of them spread out through a big area like we have in the scene, then it starts to become slow, starts to become a bit of a problem, right? There's a bit of a trick. It's not perfect. It's not perfect, but it's helpful. And it's a similar technology that, I say technology, it's a similar system that the video games use, which is level of detail. We use it in production quite a bit, and actually that's roughly what we did with this. We took a penguin that it was high resolution. This is the master, remember? Let me just show you these guys. So this guy was the master. This was the mid-res. And this was the low res, as you can remember. Yeah, we have these three little guys here. So one of them, this one, will render nicely when you close. This one, it's all right, you know, it's a bit less. But this one, in the middle, close by, you might actually see the difference. And we could even try to render it just quickly. I'm just gonna render the three master penguins. Let me just find them again. And see if we can judge the difference in resolution, right? Sometimes it's noticeable, sometimes it's not. But obviously, the closer you get to them, the more obvious it will become. And we didn't even do much of a reduction. I think we did a 25% and a 50% reduction, if I'm not mistaken. But here I can see a bit of a difference. Remember that the one in the middle is the lowest resolution. This is the highest. This is the medium. All right, so you do see a little bit of difference. And like I said, if you do a bigger reduction, then you will start seeing even more. There we go. You can see it a bit on the texturing. Maybe once you move the camera around, it will be more obvious. But right now, you know, you can roughly tell. Like I said, if I were to grab this guy and cut it in half, the resolution, then, you know, it will be more obvious. Okay, so what happens if I want to fly through these penguins and I want to use level of detail for that? So what do I mean by that? I'm just going to put them right where they all go. A level of detail will allow you to have a high resolution, or based on the distance from the camera, let's say, then you can have a high resolution penguin and then switch to medium res and to low res the further away you get from the camera, or at any given point in space. Right? It doesn't really matter. So let's try that. Let's see if we can figure this out. For now, I'm not going to use these penguins. I'm just going to hide it. And all I'm going to do is just piggyback or steal the system that I have here going on already with the penguins. So here they are. Okay. So it's just I have my particle system, I have my scaling, I have everything in place. That's good. Okay, so how do we do this? I'm going to create, just to start, just to show you this, a locator. They're very useful. And here it is. So what I want to do with an expression is just to say, well, the further away you are from the locator, then you have to switch the penguin from one master to medium to low. That's basically what we're going to say. So the first thing you need to do, okay, to get this working is to add all three penguins to the instancer. Right now, if you select the instancer, we only have the low res penguin in this scene. What I'm going to do first to illustrate it better is actually I'm going to do just three different very distinctive shapes. Sphere, let's say a cylinder, and a cone. I got these three. So I'm going to grab all three. I'm going to grab my instancer and I'm going to add them to the instancer. So you see I have the sphere, the cylinder, and the cone. I'm going to get rid of the penguin for now. So I have three. We have never done this in class. We always had one. Now I have three. Okay, so how does the instancer select which one to use? So if you don't specify an expression, if you don't specify a rule, by default, okay, Maya is gonna select the sphere. So let's see if that's true. So I rewind and hit play. It's a sphere. Everything remains the same. You see the scaling, but the rotation won't be visible unless you have a texture applied to these things, right? You cannot really see it. But you can see that there's the sphere is the one assigned to everybody. And that's because I haven't specified any other way to do this. You know, I haven't said anything about the list, select randomly or whatever. There are ways to do that. So let's go ahead and grab the particle. And how do I mess with that? How do I do that? Well, I'm going to add an attribute first. The easiest way, right? The easiest way, and that's what's going to apply when we do the forest, okay? Is just to do a float per particle, just a random number, and call them, for example, random object. Let's say random obj. And I'm going to add it. A random obj, remember, the names are irrelevant. But let's say that when they're born, I assign a random number between 0 and 3 to this guy. Why 0 and actually 0 and 2? I should do that. Between 0 and 2. Why 0 and 2? Well, because if you go to the instancer, you can see that the list has 3 items. And like I said before, that every list in my every array, which is called, the first item of that list of that array is 0. So it's 0, 1, 2. Has nothing to do with these names. It's just the item of the list. So it goes from 0 to 2. So a trick for what I'm trying to do here is then to assign a random number to an attribute in Maya between 0 and 2. Hit edit. As you can expect, because you've already been with me for quite a few hours, nothing happens. It's just a container of information. But now I can go to object index under my instancer tab of the particle shape. Okay, I go to object index and I should have random object. If I hit that, then guess what? You get, let me rewind and play because remember this is on creation. There we go. So I do get, just my wireframes and my keyboard is being acting funny. I don't get the cone, actually. I get the cylinder and the sphere, and that just has to do because of the limits of the random expression. What you can do to modify that a little bit is just to go in here, and you can tell, well, let's just check the list and see which item of the list is the cone, actually. Just grab the instancer, and the cone is item 2. And at the moment, I don't see any here. Let me just grab the cone. There's none there. And it's just because the random expression, okay, it has to select from a minimum and a maximum, and sometimes it doesn't hit 2 as the list. Of you can do is probably expand this to 3 and see if that helps. Okay, then I edit. Hit rewind, hit play, and now, okay, you can see that you have spheres, cones, and cylinders, randomly assigned. Yeah, that works. Like I said, when we do the forest, then we're gonna have a list of trees, okay, different sizes and all, and we're gonna use this kind of stuff mixed with other techniques, okay, to make a forest. That works. That's how you get, diversity into you can have multiple models of penguins with different poses, for example. Well, that will help. So if you want to grab the penguin that I gave you and put a couple of joints in the neck, for example, and rotate it up and to the side, and then make a 2-3 variations and change the textures. For example, take the texture to Photoshop, edit that texture a little bit, and then do what I'm doing here with these expressions and the object index. Then you will get a much nicer selection of penguins because it will have variation on the skin tone, on the feather tone, on the pose, and it will look a lot more real. Okay, so that's one thing. That's great. Okay, so now we have the level of detail working, but we have it working in a random fashion. What I really want to do is do it based, like I said, on the distance from the locator and eventually the camera. I do the locator first because it's easier to explain it to you. All right, so we need to just tweak a little bit the expression. It sounds more complicated than it is, like pretty much everything I say so far. It's going to be hard for me to say one day, this is very hard, very, almost impossible. I'm not saying that I can do everything, but probably the things that I cannot do, I just don't do. But it seems to be, everything seems to find a way. And I know when you're learning, sometimes it can get heavy and overwhelming. That's why, like I said at the beginning, I decided to give you a week off. Just to regain your strength and be positive. I think that the new idea of the student reel and sharing your work online is on my Facebook. It's going to be a great motivation for you. I want to keep it, like I said, as a healthy. I don't even want to use that word, but I can't come up with a new one or another better one right now. But let's not say competition in the sense that I'm better than you or you're better than me. Between you guys, no, it's just a healthy experience, so it's a good challenge, right? And I think seeing the people's reaction about your work, I'm sharing those things in groups of universities and schools worldwide. People that pay hundreds of thousands of dollars and thousands of dollars for training, and they're amazed by what you can do in a week or two. And I think that's the biggest motivation. And you have to also get used to it. I see it as a training tool as well, because you have to get used to getting criticism and comments and dealing with that. Believe me, I have to do it on a daily basis. Think about that. Everything that I do, everything that I publish is going to be judged by someone at some point. And you have to grow a thicker skin and exercise patience and compassion and being humble. And it's always good to see. It's always interesting to see what other people have to say about your work. Not many people, comment on it, because that's just the way it is. They're just shy. Even you guys, are, you know me through these videos, let's say, and soon, hopefully in person. You're still shy. I post many things on my Facebook, and I hardly get anything commented from you guys. So it's understandable. That's the way it is. But anyway, get used to it. That's the way it works. The idea is that every day when you're in production, every day at 9 o'clock, there's dailies, and you have to sit in a room with people that are as good or better than you, and show your work and defend it, and take credit. Right? So there you go. Well, I always go on the side a little bit. Okay, so I get everything settled here. So I want to do it based on distance, so it's not that hard. What I'm going to do, I could use this attribute, but the thing is that I made it a float, this random object. And position, as you know, is a vector. So, we can use the attribute, or we can do something different. I mean, it's very simple. The position of the particle, we have it. So this thing here, it can stay for now. Or remember, if you want to jump that line, then just put 2 of these. So Maya won't read that. Okay, so let's go here. So what do I need to do? Well, I need to get the position of the particle. I need to get the position of the locator and subtract. And if the distance between those 2 points is within a range that you will specify based on the scale of your scene, okay, I will teach you the whole thing right now. If it's within the range, then you select one object. If it's higher than the range, you will select a different object of the list. And if it's greater than anything, whatever you specify, then you select the other item of the list. Okay, so, well, you might be getting confused, but it's simple. Let me just grab the shape node to jump directly into the expression. There we go. Okay, so what I need to do is, I need to get the position of the particle. And you always remember that you have to store it. We did that in a couple of lessons to remove the velocity in y. I'm using position, but it's the same workflow. I mean, velocity, yes, that's one thing. Position is another, but it's the same thing. It's a vector, so you can say a vector. Give it a name, okay? I always give it a short name, $path, and that's equal to position. Position of what? The locator? No, absolutely not. The position of the particle. Remember that I'm working on the particle shape. If you hit edit, you can go one at a time, okay, in case you make a mistake or something, then you can spot it quickly. That's easy. That's a vector that carries the position. If I were to say instead of position velocity, it will carry 3 numbers, and that's the velocity. This is just the position in space of each particle. That's good. Okay, now I need to get the position of the locator. Yeah? I will teach you the easy way. I know, for example, I have a student named Bobby, and Bobby is a bit more advanced and he likes to script. So Bobby, if you're listening to this, then this is for you, man. You can always do more elegant solutions and better, and I welcome you to do it. And if you don't mind, share it with the guys so they can see a different workflow. I need to go baby steps for now, right? So to get the position of the locator is easy, right? What I'll do, okay, is just get 3 numbers and build myself a vector. I'm just also doing it this way to show you, how it's not that complicated. It's not that locked, mail scripting and everything. It's not that bad. A vector, that is 3 numbers for X, Y, and Z. Well, what I'm going to do, if it's a number, is called a float. Okay, it's not a vector. Remember that a vector is a variable, a container. Okay, or think about it like I said the other day. with a plastic bag. Think about it as a Tupperware. Okay, the vector or the variable is a Tupperware, and depending on the type of Tupperware that you carry, then you can have multiple types of food. Let's say. So a vector variable is a Tupperware with 3 spaces. So you can have, for example, I don't know, chicken, rice, and beans. Yeah, X, Y, and Z. A container with 3. A float is a regular Tupperware where you can carry one thing. You cannot mix that. Right? You cannot mix all those things. So in a float, I just carry one item. So in the float, it's the same idea. I'm going to call it, for example, I should name the locator. Well, you can name the locator or just keep it as it is. And then I can say locator X pause. The naming doesn't matter. This is something that I'm giving myself to remember what I'm doing. Or if someone else picks up my scene, then they can see roughly what I'm doing with this, where I'm going. And this flow, this container, this Tupperware with one item, is going to carry, okay, locator 1, which is the name of this guy. I should have renamed it before, but I can rename it after. Locator 1 dot and the name of the attribute. So it's going to carry, that Tupperware is going to carry just the translation in X. It's going to carry my rice. I need to make 2 more to carry the chicken and the beans. I know it's a big ghetto, those analogies that I make, but I think that you will remember it that way when you're working. So, and I'm not hungry, I already ate, so it's not about that. dy dz. Simple, right? This is the name in X, the name for Y, the name for Z, and that's going to carry locator 1, and I shouldn't do these spaces. It should be all one word. Translation in X, translation in Y, translation in Z. You hit OK. So far, so good. Again, all we have are Tupperwares with food. We haven't really assigned that to anybody's lunch. We haven't really decided who's going to eat that, who's going to use it. So that's fine. So far, we have that. That's good. So what do we do now? Because I have now a vector, okay, a container with 3 spaces, and I have 3 little containers of 1 space each, okay, 3 variables, 3 floats. What I want to do is a subtraction now between the position of the locator and the position of the particle. But I cannot subtract, okay, a vector variable with a float. They have to be the same kind. Yeah? They have to be the same kind of variable. So what I need to do is convert these 3 items into a vector. And that's very simple. Okay, so what I can do is, well, you know what? No. Let's do the subtraction directly. I think it's going to be more fun. Okay, so the subtraction. So if I'm going to subtract a vector, or if I'm going to do a subtraction of positions, let's say, they have to be vector. Okay, they have to be a container of 3 spaces. So basically what I'm going to do is take the rice from one container, subtract it with the rice of, the one with the 3 spaces container. I'm going to subtract the rice with the little one, and the beans with the little one, and the chicken with the little one. So I'm going to make just a combination of everything, right? And because the combination is a vector, I'm going to name this vector, okay, whatever you want. Let's just call it distance. Anything you like. This vector is going to be the result of the subtraction of the position of the locator minus the position of the particle. Each particle with the locator, right? So this distance, okay, is going to be equal, because it's a vector. Remember, you have to specify like this. And what are we going to subtract? Yeah, I'm going to subtract this item, the position in X of the locator. You can put a parenthesis if you want. It makes you feel safer. Okay, the position in X of the locator minus, okay, the position in X of the particle. It's called $POS.X. I'm subtracting rice with rice. Yes, in a new 3-space container, Tupperware. 3-space Tupperware, rice from 1 minus the rice from the little guy. Yeah, done. That's my X position. Remember that this class is meant to mess with your head. So if you're feeling confused, that's good. That's the way it is. If you, Bobby, you're a special student, then this might be simple, so you can skip ahead or start thinking of better ways to do this thing and share them. Yeah, don't be selfish. All right, cool. So that's position in X minus position in X, and then because I'm lazy, I can just copy this, paste it, and paste it, and it's very simple. You see, that's why math scripting starts to get simple when you start copy pasting things. There we go, perfect. Position in Z minus the position in Z. Okay, we're subtracting the same kind of items and put them in a new Tupperware. Beautiful. It is. Edit. Well, so far so good. No mistakes. That's a good thing. Okay, so now we have a vector, a new vector that is the subtraction of these two positions. What do I do with that number? Because it's a vector. Okay, a vector is just like 3 numbers. And if I want to use it here under my object index in reality is just a number. It's just 0, 1, and 2 in my case. In this case, see, I have 0 for the cylinder and 1, for example, for the sphere, and 2 for the cone, whatever. So I cannot really use a vector. So what I need to do is get what is called the magnitude of a vector. And that's something that I will advise you to research on your own a little bit. You will do something like this. Vector magnitude, if you see images which are faster, the magnitude of a vector is the length of the vector. So you take 3 numbers and you combine them and you form 1. That magnitude of the vector indicates how strong or how big that vector is, let's say, in simple terms. And that's how you turn a vector into a float, into one number. So now I can use float, and let's say, let's just say whatever name you want, right? But let's just say LOD for level of detail, for example. I don't know. No, let's just not confuse you. Let's just put there a mag for magnitude. And that's simple. That's the magnitude of a vector. Okay, how do you do the magnitude of a vector? If you get stuck or if you really like Mel scripting, then you can go into the Maya scripting reference for Mel. You open it up and this is going to become your best friend. So now you can specify mag, I believe, and mag is here. This command returns the magnitude of the length of an argument, well, a vector in this case, right? It's a magnitude of a vector. And it teaches you how to do it. So you can see here, the magnitude command, okay, takes a vector, which is this one, and then it gives you the length. And that number is the real distance, is the magnitude of the distance between the particle and the locator. Because it's not really positions, it's a length. So how much distance there is between here and here, or between this particle and that locator. That magnitude is what is going to become that. And to do that is very simple. You specify mag, like the example says, and then the name of the variable that carries that. There you go. So to recap quickly. Position of the particle. Cool. Position of the locator in each axis. Done. Subtraction between one and the other. Done. It returns a vector. Now, the magnitude of the vector to see how long that distance is, here it is. Beautiful. Now I have that number. I have a vector, I have a number, a float, one number, sorry, that carries the distance of the particle and the locator. That's done. Okay, so what do I do with that? Well, now you can specify things. I'm just going to hit edit, no mistakes. Nothing is going to change. The next thing I want to do is just get bearings of the scale of my scene, how big this thing is going to be. And there is a little tool right here, very cool, that it says distance tool. So the distance tool will allow me to specify, for example, 1 and 2 points in space, and it will give me the distance. I can see that between here and here, roughly, 1 unit of this grid. Okay, you can see the locators right there. And it's cool because it's interactive. You can move one locator, it creates, you see, these 2 locators. You can move one if you want to. and get the distance updated in real time. Why am I doing this? Well, I want to judge what is a good distance for me to change level of detail. Let's say this distance, 28, let's say 30 to round it up. Okay, so every 30 units I get away from the locator, I can change to a different level of detail. And you will adjust this as you wish. It's up to you. I'm just showing you that this tool is useful. It's right there. And it says 30, so I think I'm fine with that. I'm gonna leave it just to show you later if it works. Okay, so 30 units. Why do I want to know that? Because I need to go back to my expression and start setting some conditions. So what am I gonna say? Well, I can say a condition, right? I can say if, right? The name of the variable is $mag, okay? It's the dollar magnitude of that particle. Actually, you know what? Let me just show you. Let me just show you something. 1 second. Because I want you to see it. I want you to see the numbers. I want you to see what is true. So I'm going to use this guy. I'm just going to steal it. This attribute that we create per particle, remember? Random object. No, don't think about the name. What I'm going to do is just assign in here the magnitude, right? Just so I can display it. So what are you talking about, Luis? Well, now it's assigned, right? I have an attribute per particle, remember, called random object, and that is equal to the magnitude of the distance, so to the length of that vector, the distance. So this is going to print the distance. So if I change my particles from point to numeric, okay, and I specify here random object, guess what, brothers and sisters of my group? Check this out, baby. These are the distances, and it's true. 4 units, 8. You can use this to make it, make sure that that's true. Up to 51. 51 means what? There is a vector. Think about a line. Okay, think about getting in hell. Why won't we try it just to see? Let's see if we move this guy, this locator, okay, to the point where this locator is roughly, right? So this is my origin, and this, you can put it in any particle you like and see if it matches. And look, man, it does. This is freaking genius. I'm not saying I'm a genius. I'm just saying that I love when these things are cool, and I know that you're getting excited and you're thinking of many things. You get a little fear in your stomach. That's normal. But I want you to try and look, man. Roughly. I haven't been able to place it in the exact position. I can probably do that. Roughly. 49.6. And this says 49.56. So I just have to move it a tiny bit just to match it. It's beautiful, man. It works. It does work. What do you think? I think it's great. So it does match, okay? So this is the perfect illustration of what we just did with all those expressions. And it seems like a lot. It seems a bit convoluted, but it's not. It's very simple. So there you go. You get a real representation of distance, and now you know the exact number of the position, the difference between the locator. You can move the locator 1 as well, and you will see how the numbers update. Aha, they don't update. Why they don't update? Because it's simple. We're missing one step. We place this expression on creation. Yeah? We need to take the whole thing, copy it, and also put it in runtime. Done. Now, you can grab the locator 1 in this case, move it, and look at all these values changing. Yeah, you got it? You see it? Let me hide the instancer so it's better for you to look at it. Let me just hide this. Oh, damn it. Display, hide selection. All right. Look. If I move around my locator, just rewind, forward 1 frame, and here's like my distances. And it'll update, okay? So you go 1 frame forward just to reevaluate, but you can see that all the distances are being updated, okay, in real time. Right. So we have that. We haven't finished, but all we need to now we that we saw that it works. We can just specify some criteria for switching, and it's good that I have this thing set up over here. Where's my my locator one is my center, and this is my limit, and this helps me because I can see now that there is no penguins being born past this point. So this is going to be my maximum, let's say, limit, where the guys with the lowest, if I'm filming from here, right? I'm just assuming that this is a shot that it goes from the center out. If you will tweak it later to fit any situation. But I can see that I have 50 units, let's say. Okay, so that's good. I'm gonna get my particles. I'm gonna put them back to point so you don't get confused. One thing that we should do is save. Huh? We haven't saved. All right, cool. We saved it. Let's do some conditions. Okay, now we can go and say, we can start on creation. Doesn't matter. We have to do it in both anyway. So we can say if, okay, $mag, okay, is, let's say, less than, and I'm not reading a script. I'm just thinking, right? I'm just thinking, well, less than what? I can just mix. You can just say, I think we said, if this is 50, let's just split it in 3, like roughly, right? Let's say 15, just to begin. Okay, so if it's less than 15, then what do I do with that? Well, I can just say, that's not what I want. That's what I want. Remember that my conditions always have to be inside these brackets, yes? Okay, so what am I going to do with this? Well, I can just use the attribute that I was displaying somewhere here. Random object. So I'm going to grab this, I'm going to cut it, I'm going to place it, and I'm going to say that my random object is going to be equal to 0. For example, assuming that 0 is going to become the penguin with the highest resolution. So if the distance, okay, is less than 15, then use item of the list 0. 0 is going to become the highest resolution penguin, remember. Okay, done. Easy. Copy, paste it, and paste it. Let's just say for 3 levels of detail. This is going to become item 1 and item 2. If you had 10 penguins, then you have to do this 10 times. But it's easy. Copy, paste it. The second one, it has to be higher than 15 and lower than, let's say, 35, for example. So I can say if the dollar magnitude, okay, is greater than 15. How do I say 2 conditions? It had to be 2 conditions. And again, I know that there's a more elegant, shorter way to place it, but I just want to do it like this so you can understand. So if you want to put 2 conditions, then you have to put double ampersand, this one here. So you can say here, if the magnitude is greater than 15 and also is, let's say, lower than 35, this will happen. So it has to comply with these 2 conditions. It has to be within 15 and 35. Not bad at all. And the later one, it has to be greater than 35. That's it. Hit edit, no problem, no mistakes. Excellent. Copy. I think we got, let me just think, I think we got somewhere there, right? Well, I can copy the whole thing. I can just open this bigger. You copy the whole thing, which starts here, and place it down here. So, down there. If you want, I know when you start doing more and more expressions, you're going to have to keep things organized. Remember, if you put these 2 things, then you can specify, for example, a divider. And you can say what's happening. So here we're going to do level of detail expressions, for example. It's just to get things are more organized. So down here, if you were to do something else, that you will, specify, or you can just say n of L of D. This is just, again, for your fellow co-workers or for yourself if you have many things. Yeah, you can just keep things nice and neat, organized. Maya's not going to read this line, but it helps you, you see, divide things quickly. So really visually it's easy to locate everything. So no errors, no mistakes. Okay, so all we need to do now is go back to the instancer and tell it to use, well, it's already using random objects. So let's see what happens. We need to show the instancer because I'm hiding it. Show selection. All right, let's see what it's doing here. Let me hide this sunlight. All right. And I may also hide the floor just so we can see what's going on here. Check that out, man. The further away, okay, you get from this locator, then you get cones. Then as you get closer, you get cylinders and then spheres. I'm gonna get rid of this just to have less clutter in my scene. Use my locator 1. We can test it, move it, and see how things change. The further away I get, eventually, they all become cones. Right? Look, cylinders, and then last one, cone. Cool. As I come closer, they start to switch. Cylinder, cylinder. I mean, look at the cylinders, and then as I start getting close by, then we get spheres. Look how it changes. And because the particles move on their own, let's just see. Let's just leave them like that. I don't know what is easier to see. I think it's like this. And have them move. As they come closer, you see how they switch? Again, further away. Let me just do this angle. Cones on the edges, then cylinders, then spheres in the center. As they come in, they switch. From cone to cylinder, from cylinder, eventually, depending on the distance, to spheres. Check that out. This is cool. This is very, very, very cool. Very useful. You will find many applications for this. But it's going to save you a lot of time. Those are simple expressions that Maya can evaluate quickly, and it will allow you to have low, less polygons in your scene once you have large numbers of birds. Okay, so this works. All we need to do is just swap whatever the instancer is using. So I have my instancer here with sphere, cylinder, and cone. All I need to do is grab my penguins, which are right there. Just find them. And the trick is, don't get overexcited and go ahead and delete from the instancer right away these things. Don't do that. First, add the birds and add them in the right order. First, select the master, which is high res, remember? Depending on the expression. Then mid, then low. Then grab the instancer, add them, master, mid res, and low res. Grab these 3 guys that you don't need anymore, remove them. Anyway, you can move them up and down if you make a mistake, but I like to select them in the right order. Okay, so that's done. I get rid of these 3 things that are messing with me. And now, ladies and gentlemen, let's see. Get my penguins over there. I'm going to rewind and save. Remember that the instancer doesn't have to be, the main geometry doesn't have to be visible. But now, I get penguins, and as they move, they will switch resolution. But I don't believe you, Luis. You don't believe me. Let's see if we can find a way to see them closer, probably to see them change level of detail. We could follow one. Let's say this guy. Let's go to the edge. Oh, look, perfect. We have this guy here, a lonely guy. All right, let's see what he does. I think it's better that way. So he will move very fast. And then he will change. Well, I think we're going to have to do it with textures to see them. But that's the beauty of this. It does work, and it doesn't really feel too much, right? Because the models are similar in resolution. So I mean, yeah, it's not that much of a change in resolution, so you won't see a big jump like you saw with the cylinder. And that's why I did it that way. Okay, but this way you will have, and like I said, with what we're gonna do is just different textures. I think it'll be the easiest way for you to see them. So let's say master has this texture. Let's just add a different material to the other ones to visualize them easier. What do you think? Or if you wanted to see if it works, okay, the easiest way will be probably to grab and make them the mid-res longer, for example, and the low-res even longer. Let's just say, for the sake of testing, if you say you don't want to change textures, right? And hopefully, if everything works, then you will see them shrink in size. I think we're going to need more penguins to really see it. Okay, so let's keep an eye. Some of them should start shrinking as they get closer. Just pick one and follow it in your eyes. There we go. I can see it working. Hopefully you can. If you cannot, don't panic. I'll solve it for you. Make it quite easy to judge with the texturing. And I think it's a good way for you to try it. So this guy, you can just put it back to 1. And this one, well, let's just grab all 3. And put Y back to 1, so they're all the same size. So master stays the way it is. Let's just say the mid-res is going to have a different material. Just for the hell of it, right? It's just to try. So let's make a Lambert for the second one, which is Lambert 4. Assign it. And I'm going to make that one, let's say, red. Yeah, you can see. Okay. And the low resolution will make another material. I don't know. I don't like this window here. Get out. Okay. I'll make another Lambert. Assign it to the low res. And we'll make this guy, let's say, yellow. Yeah, so we got yellow, red, and then here it is. Let me just give you a few more penguins to play with, so you can really see it. There we go. So they go from yellow further away to red, and then they start to switch. You can see when they start reaching this region here, they will start switching to regular texture of the regular penguin. There we go. This is a three-dimensional thing. You can have them positioned in Y. You can have them, placed anywhere you like, and it will work because remember, it's calculating the distance from 2 points, which is perfect for what you want to do. So that's very cool. Done. I think with that we can stop this lesson. I don't want to keep them too long so you don't get bored. So let's save this one in case we need it for later. And well, I'll see you in the next one. Thank you.